Yesterday, one problem was discussed on projectile motion. Try to remember, projectile motion means one stone was thrown with an inclination of alpha with the ground, with an initial velocity of u. And at the end of the journey of the stone again reaches to the ground, means same horizontal level. Uh, you have seen that the range R was, the expression for range was u sine 2 alpha by g. U, initial velocity, multiplied by sine 2 alpha divided by g. So you can easily see that R will be maximum, that is range will be maximum when sine 2 alpha will be maximum. And maximum value of sine 2 alpha is what? It is 1. That means it is sine 90 degree. So 2 alpha is 90 degree, therefore alpha is 45 degree. This is known to you already. Still I have repeated this one. So for an angle of 45 degree, the range will be maximum. This is correct only when the initial point of throwing and the final point of touching the same horizontal level are same. Okay. Means vertical displacement in this case is 0. If vertical displacement is 0, only in that case, for an angle of 45 degree, the range will be maximum. But in the second case, one more case was discussed in another video, where the stone was thrown from the top of a tower. Height of the tower was denoted by small h. In that case, for maximum range, alpha will not be 45 degree. Most of the students make this mistake. When the stone is thrown from the top of a tower or from a top of a building, what is the difference here actually in these two problems? Difference is that in this case vertical displacement is not 0. When vertical displacement is 0, only in that case for an angle of 45 degree the range will be maximum. But here in this case vertical displacement is minus h. Try to see the previous video, you will get there that final displacement is here minus h. And the time of flight, okay, the maximum, the total time of flight, it is not, to calculate this total time of flight, you have seen that you will get one quadratic equation. Quadratic equation in t means t square term will be there, square of time will be there, again one term will be there, only t, that is power of t will be 1, and one constant term is there. And in that equation you will find h is there, means height of the tower or height of the building. H is there, again the angle alpha is there. So when you will solve that quadratic equation, you will find that the total time of flight depends both upon the height h and the angle alpha. Okay, total time of flight depends both upon height and the angle alpha, and of course the initial velocity. Okay. So here if initial velocity and h are fixed, say they are constant. Say u is given, it is 50 meter per second, 50 meter per second. H is given, it is 100 meter per second. Then in that case, we will get a value of total time in terms of alpha. Okay. Using that value in the equation for range will be what? U into cos alpha, that is the horizontal component of the velocity, multiplied by the total time. Okay. So in that case, you will not get that sine 2 alpha term. You will get something else. And differentiating that expression with respect to alpha, you will get one derivative, dt d alpha, derivative of total time with respect to alpha. Okay, make it 0. And you will get corresponding value of alpha. And you will find that this alpha is not 45 degree. This alpha depends upon h. And of course, the initial velocity. So h, this term is there. Alpha will not be 45 degree. Yes, in this expression for range, if you put h to be 0, you will get again 45 degree. If you put h to be 0 from ground to ground, means same horizontal level. Okay. But if h is not 0, then angle alpha depends upon h. Okay. You just get those equations. Have a look on those equations. You will understand this thing easily. But I have seen that most of the students make this mistake. They think that for any case, for maximum range, alpha should be 45 degree. That is not correct. That's why I have made this video. Okay. Thank you.